In this video, we're going to create a simple melee combat system. We're going to have our player that we can move around, enemies will be spawned and we'll be able to attack them. The targeted enemy will depend on the attack direction, so we can choose which enemy we want to attack. Let's begin! Hello and welcome, I'm your Code Monkey, and this channel is all about helping you learn how to make your own games with in-depth tutorials made by a professional indie game developer. So if you find the video helpful, consider subscribing. Okay, so here's what we want to make. Over here is my player character, and I can move him around normally. This is using the character controller that I built in a previous video, so check it out. And as you can see, I've set the camera system to follow the mouse position slightly. And by clicking on the mouse, I can attack towards the mouse position. So I click here, attack to the right, attack to the left, and so on. Now I can spawn some enemies. And yep, there you go, there he comes, and he comes towards me. Now he's using the basic enemy AI that I covered in a previous video. So essentially the enemy chases me, and when he's close enough, then he starts attacking. And now if I click, yep, there it is, I do my attack towards the enemy that is closest to my attack position. When I hit, then the enemy gets pushed back, and the player moves forward. With enough hits, then the enemy simply dies. Now, if I do get surrounded, so I spawn a whole ton of enemies. So there you go, now I'm surrounded. And now since the attack is based on the position towards the mouse, I can actually select which enemy I want to target. So let's say I want to attack this one, I click up there, and there you go, I'm attacking that one. Now I want to hit this one, and click there and there. So I can select individually which enemy do I want to attack. So the find target algorithm is looking for the closest valid target based on the direction towards the mouse, and then it attacks that enemy. Okay, so here is our nice and simple melee combat system. This is the exact same system that I use in Hyper Knights, which is the action strategy game that I made, which you can play included in the game bundle. Being able to target individual enemies was an essential part of the game, and this is the solution that I used. This video is made possible thanks to these awesome supporters. Go to patreon.com/unitycodemonkey to get some perks and help keep the videos free for everyone. Alright, so this is our goal. Let's get to it. Okay, so here's our starting scene. I just have the player character standing around doing nothing. He's just standing there playing a simple idle animation. If you want to know how my animation system works, then check out the mesh video. It's all based on dynamically modifying meshes in runtime. I can also move them around with some very basic movement. Okay, so in the editor, here is the player game object. And you can see that it has the character controller script. This was fully created from scratch in a previous video, so check it out if you haven't seen it yet. Here is the script, and it's actually very simple. We just have an update listening to inputs to calculate our move direction vector. Then we take that move direction vector and we apply it using our rigid body physics. So a very simple basic character controller. And now that we have this, the first thing we want is for our character to attack. So first let's begin by listening to our mouse click. So inside our update, let's do a input get mouse button down. So when we have a left mouse click, just for testing, let's do a simple pop-up. So just for testing, I'm using this function from the CodeMonkey utilities, which as always you can grab for free from unitycodemonkey.com. So now when we click, we should be able to correctly see a pop-up. Let's test. Okay, here we are, and I click, and yep, there you go, we have our attack. Alright, so we're listening for mouse input. Now that we have this, let's calculate the direction towards the mouse. That's what we're going to use in order to target our enemies. So to calculate the direction, first we grab the mouse world position. So again, we can use a function from the utilities to get the mouse world position. Here is the function in case you want to make it yourself. All it really does is takes the world camera and does a screen to world point on the mouse position. So we grab the vector 3 for the mouse position. And then in order to calculate the vector 3 for our attack direction, we just take the mouse position minus this transform position. So to do, let's do a pop-up saying our attack direction. And let's also normalize our vector. Alright, so let's test. Okay, here we are. Let's click on the right side. And yep, there you go, 1, 0, 0. So we have a vector to the right. Now here on the left, -1. Up, we have 1. And there, -1. And everything in between. All right, awesome. So we correctly capture our mouse clicks. And we have the direction towards the mouse, which is going to be our attack direction. Now let's just play the animation. So for the animations, again, I'm using my animation system. And I have a simple function here on the character base. Just play the attack animation. It takes in an attack direction, and then a delegate for the animation complete, and for now let's just ignore it. Alright, so let's see if it plays the animations. So here we are, and click, and look at that. We did correctly capture the mouse input, but there's no actual animation. So I can still move, and click, and nothing. Now the reason for this is actually pretty simple, and if you follow the character controller video, then you know exactly what's happening. So over here is our code. So we have our update, we're handling our movement, and then we're handling our attack. So the issue that we have here is the same that we had with our rolling code. So we start the attack animation, but if we stay in this state, then on the next frame, we're going to go through the update again, and we're going to cancel the attack animation with our simple move animation. So the solution is the same as the dodge roll that we covered in the character controller video. So let's go up here in order to define a new state. So we have the normal state and the attacking state. Now we field to store our current state. And by default, we start off at normal, okay. And now in our update, we do our simple switch on our state. So we have our normal state, and during our normal state, we play the normal move animation, and then we listen to our inputs and we play the attack animation. And it's in here that when we play the attack, that we need to modify our state into our attacking state. And here, in case we are attacking, we're not going to do anything. And then when the animation completes, let's reset the state back into state.normal. Alright, so that's it. Let's test. Okay, here we are. Let's put mouse in here and click. And yep, there you go. We have our very nice attack. Alright, so it seems like it's working. We have the animation playing correctly towards the correct direction. However, we still have an issue. The issue is if we attack whilst moving, so move and attack, and there you go, the character keeps sliding. So move, attack, and keep sliding in that direction. So the reason is because we set up our character controller in order to work with physics. So if you look at how we implemented that, here on our update, we calculate our move direction, and then on our fixed update, we are setting the rigid body velocity. So when we start attacking, let's make sure that we put our move direction back into vector 3.0 so we stop sliding. Let's see. Okay, so here we are, and click, it still works. Let's move and click, and yep, there you go. Now he stops to attack as he should be. All right, great. Now we have one final issue, which is the rate of our attack. So right now we have to wait for the attack animation to fully complete in order to do another attack. So naturally, this is going to depend on what type of game you're making. So maybe if you're making something like Dark Souls, where you want every attack to count, then this would be a good system. However, I want the attack to be snappy, so I want to attack every time I press the mouse, and I want that to work even whilst in the middle of another attack. So let's do that. Alright, so first of all, let's clean up this code. So let's make a private void, call it our handle attack function, and we're going to pass in our attack code in there. And we can also comment out the pop-up, okay. So then here we call our handle attack, and let's also clean up the movement. Alright, so everything is still behaving the same. We just made our code a bit cleaner, so we have a function to handle the attack and one to handle our movement. So when the state is normal, we are handling the movement and handling the attack. And now what we need to do in order to make our attack be very snappy is all we need is to make sure that we handle the attack also while attacking. So that way we can attack while still in the middle of another attack. So let's see. Okay, here we are moving around and click. And there you go. Now if I spam the clicks, I can actually spam the attacks. So the attacks are now very snappy. So if I go and I attack 3 times, and yep, there you go. Just like that. Right, great, awesome. So again, this is going to depend on what game you're making, but in this case, I really like having some very quick, very fast attacks. Okay, so we can capture our clicks and play the attack animation. Now let's actually hit some enemies. Now I already set it up to spawn some enemies when I press a button. So if I spawn, there you go, some enemies get spawned, and they chase me, and they get close, and they start attacking me. So the way they do that is using the basic enemy AI that I covered in a previous video. So they come towards and attack, but right now I cannot really attack them. So I can click on them, but nothing really happens. So let's figure out how we're going to attack our enemies. Now the goal here is to attack the enemy nearest to where I'm aiming with the mouse. So what we're going to do is calculate the position and look for the closest enemy. So for example, I want to be able to click on this one and attack this enemy, and then click down here and attack this enemy. So we don't want straight up just the enemy closest to the player position. We also want to use the mouse position in order to calculate the enemy that we're going to attack. So instead of the player position, we're going to calculate a position towards the mouse and then look for the enemy closest to that. So here on our handle attack, let's calculate a vector 3 for our attack position. And now the attack position will be our transform.position plus our direction towards the mouse. So let's rename this instead of attack direction to the mouse direction. And we're going to make our attack position be based on our current player position plus the mouse direction and multiplied by a certain amount. So if we set the offset to 0, then it's just going to be the enemy closest to the player, and if we set it to more than 0, then it's going to be more towards the mouse. But if we set it too far, then we might actually grab an enemy that is very far from the player. So let's use a value that is about the player size, so in this case it's about 3. Okay, so let's test this out. So in here let's do a debug log on our attack position. And now let's test. Okay, here we are. Let's click on the right side, so click. Now let's pause. So that's our attack position. Now let's create the game object just to be able to visualize it. So in here, put it in there. Alright, so we place the game object on that position, and yep, there you go, it is indeed on the right side. So we can probably increase the offset by a bit more, but yep, it is going towards the direction that we want. Okay, so when we click, we want to test for the enemy closest to the attack position. So now let's check out the code inside of the enemy class. So first of all, here is the enemy spawner, just a basic script added into a game object. And we're just testing for an input get key down, and we're calling the create function on the enemy class. So let's look at it. So here is the enemy class, and we have the function to create, which just instantiates a prefab. And then we just have a very basic enemy AI script. Again, I covered simple enemy AI, so check it out to find out how this works. But now that we have the enemy class, how we're going to find the closest enemy is, first of all, we need to actually know where all the enemies are. So we need to store a list of all of our enemies. Now we can define it right here. So we define a private, make it static, so we only want one list for the enemy class. Let's make it a list of type enemy. So we have our enemy list, and now here we have our spawner function. So when we spawn an enemy, let's add that enemy onto our list. Now if we just do it like this, we're going to have an error since this enemy list will be null. So before we do that, we test if the list is null, then we create a new list. Alright, so now when an enemy gets spawned, it gets correctly added onto this list. Now let's also remove dead enemies from the list since we don't want to target dead enemies. So down here there's a die function that gets called when the enemy dies. And in here we just go into the list and we call remove and pass in this. Alright, so that's it. Now we have a list that contains all of the alive enemies inside the world. So with this list, now we can finally look for the closest enemy. So here in our class, let's make that function. Let's make it public, static. We're going to return an enemy. And let's say get closest enemy. And we're going to have a parameter for the position and a float for the range. So we want to find the closest enemy within this range closest to this position. And now here, let's just do a very basic list searching algorithm. Alright, so here we have a very basic list searching algorithm. So we start off with a field for the closest enemy, and we start off at null. Then we cycle through our entire enemy list. The first thing we do is we check if this enemy is within the valid range. And if not, if he's too far, then the enemy is too far, so we simply skip onto the next enemy. If it is within range, then the first thing we do is check if we already have a closest enemy. And if we do not have one, then this one becomes the closest. However, if we already have a closest enemy, then we want to select which one is closer. So we do a simple distance between the position and the test enemy, and if that one is closer than the position and the closest enemy, then this one becomes the new closest. And at the end, we simply return it. So that's it, a very basic algorithm. And just one more thing, which is in here we might have the enemy list set to null if we try to attack before we try to spawn one. So let's simply test for it. So if it is null, then we just return null. All right, there it is. Now that we have this, we can go back into our player. So here we already have the mouse position, mouse direction, attack offset, and the attack position. This is what we're going to use. So here we go into the enemy class in order to get the closest enemy. Now the closest to a certain position. So in here we're going to use the attack position that we calculated previously. And now for the attack range. So we want this to be big enough so we can actually find closest enemy, but not too big so that we attack someone that's way too far. So let's use this. And now this returns our target enemy. And now this one can be null, so we need to make sure we test for that. So if this one is not null, then we do have a valid enemy. So then the enemies have a function in order to simply cause some damage. Alright, so this should be working. Let's test. Okay, so here I am. Now let's press the button in order to spawn an enemy, and yep, there he is. He's attacking me. Now if I click straight onto him, yep, there you go, we correctly attacked him. But if I put the mouse away and I click, there you go, now I'm not attacking him. So this way we can easily target our enemies. So if I click here and don't attack him, I gotta click near him in order to actually deal damage. And after a while, yep, there you go, he dies. So now let's spawn more enemies so that I'm completely surrounded. Alright, there it is, and now, yep, I can actually target them. So I target that guy, then I target this guy, and there you go, now I can individually hit every single one that I want. Alright, awesome. Okay, so now that we have the basics working, let's add some polish. First, let's make the enemy get knocked back when he gets hit. So here on the enemy class, let's look at the damage function. So there it is right here. As you can see, it just spawns some bullet particles, which I covered in a previous video, and spawns a damage pop-up, which again, also covered in a previous video, and it has a health system in order to cause some damage, which was actually the very first video on this channel. So we're already using a whole bunch of interesting effects. And now here, let's also add a nice knockback. Now, in order to knock back, we need to know the direction. And in order to calculate the direction, we need to know the attacker position. So let's receive that in our damage as a parameter. So a vector3 for the attacker position. And now we can calculate a vector3 for the direction from the attacker. So that one's going to be this transform position minus the attacker position. And we normalize it. Alright, so we have direction from the attacker, and we can also use that when spawning our bullet particles instead of a random direction. Okay. And now with this direction, we can actually apply some knockback. So I can modify transform position plus equals the direction from the attacker times a certain float for the knockback distance. Alright, that's pretty much it. Now let's go into the player script. And in here, when we pass in the damage, yep, let's pass in this transform position. And now since the enemy has a knockback, let's also send the player forward. So we're going to send him forward on the attack animation position. So we just modify the transform position plus equals the mouse direction multiplied by a certain float for the dash distance. Alright, so that should do it. However, in here we're still using the mouse direction, which isn't really accurate right now, since the position should actually snap onto the target enemy. So instead of using this, let's make a vector3 for the attack direction. And by default, the attack direction will be the same as the mouse direction, except when we have an enemy. If we have an enemy, then the attack direction becomes the direction towards the actual enemy. And then it's this actual attack direction that we use to play the animation and to do our nice little dash. Alright, so that should be working. So let's test. Okay, here we are. Let's spawn some enemies. And there you go. Look at that one. And now as I punch him, yep, there you go. He gets pushed back and I get pushed forward. So just like this, it looks very nice. So move and hit this guy, hit this guy. Now I'm surrounded, but I can actually target them, and just like that. Alright, so here we have our fully working melee combat system. So I have my player that I can move around. I can click to attack, and the attack goes towards the mouse position. Then I can spawn some enemies. Now when they are in range, I can click to attack them. However, if I click away, then I do not attack them. So I'm using an actual attack position in order to calculate the closest enemy, rather than just closest to the player position. So they take some damage, and after a couple of hits, they die. Yep. And if I am completely surrounded, then I can use the mouse in order to aim at whatever enemy I actually want to hit. So I want to hit that one, and I want to hit that one, and now that one, and so on. So here is our nice and simple melee combat system. This is the exact same system that I used in Hyper Knights, which is the action strategy game that I made that you can play included in the game bundle. This video is made possible thanks to these awesome supporters. Go to patreon.com/unitycodemonkey to get some perks and help keep the videos free for everyone. As always, you can download the project files and utilities from unitycodemonkey.com. Subscribe to the channel for more Unity tutorials, post any questions you have in the comments, and I'll see you next time.